Save the formula in Name Manager so it becomes callable on any cross-tabulated range anywhere, just like any native function. Welcome to the session. Many spreadsheets arrive with data spread horizontally across columns. It can be product names, months, categories, or anything. That format looks clean, but it breaks every pivot table, every chart, every analysis. What's needed is a vertical row-based layout. The data unpivoting formula we are going to create today converts any cross-tab table, no matter how many rows or how many columns containing any sort of data, into a flat normalized list with a single formula. No Power Query, no helper columns, no VBA, just one elegant self-contained lambda expression. That is exactly what gets unpacked in today's session. Let's get into it. The source data occupies the range A1 to G6, a classic cross-tabulated layout. The first column holds row identifiers and the first row holds column headers, and the interior cells contain the actual values. Start with lambda. Declare a variable named RNG, and before moving forward, outside the function, reference the data to this variable. Three structural components are extracted from variable RNG inside the let block: row header, column header, and data. Each one is obtained by slicing RNG in a specific direction. Row header represents the list of row labels, the identifiers running down the left side of the table in first column, whereas column header represents the list of column labels, the category names running across the top row of the table. Data contains the actual values, the interior of the crosstab table. Use CHOOSECOLS function to retrieve the first column from variable RNG by passing 1 as the column number argument. The result is then wrapped in drop function, where 1 in the row argument discards the first row, the top left corner cell, leaving clean list of row labels only. Use CHOOSEROWS function to retrieve the first row from variable RNG by passing 1 as the row number argument. Again, wrap the expression in drop function. Skip the row argument, then pass 1 in the column argument to exclude first column, returning a clean horizontal array of column labels only. For data, use drop function. RNG as array argument, 1 as row argument, and 1 as column argument. This expression isolates the interior values by simultaneously excluding the first row and the first column from variable RNG. With the three structural variables defined, the formula enters its core logic. Bring in reduce loop that iterates over every column in column header. The accumulator argument is initialized with a single row array forming the output table's header row. Pass the array column header in the second argument. Within the output argument of reduce, a lambda function is introduced accepting two parameters: ACC, which carries the accumulator from reduce, and current column header, which receives the current iteration's value from column header array. Before any stacking logic executes, a let function is opened to define column number, variable that stores the positional result of match, which searches the current iteration's value of column header through the entire column header array to determine its position. Select match type as 0. Over to next action. On every iteration cycle, VSTACK appends the newly calculated block of rows to ACC, causing the output array to grow vertically with each pass until all columns in column header have been processed. Inside VSTACK, HSTACK is responsible for assembling the three output columns side by side, combining the row labels, the repeated column label, and the expected values into a unified horizontal structure on each iteration. Row header provides the left column, the row label for every data row in this iteration. The second column requires the static value of current column header to be repeated across every row, parallel to the row header array. This is achieved through MAKEARRAY, which constructs an array of a specified size filled with a defined value. The row argument of MAKEARRAY is supplied by rows function that determines the required number of rows by referencing the row count of the row header array, ensuring the repeated column label spans exactly as many as there are row labels. The column argument is set to 1, restricting the output to a single column. Within the output argument of MAKEARRAY, a lambda function is introduced, accepting the row and column position of each cell into R and C variables respectively. In the output part of this lambda, rather than performing any calculation using R or C, a fixed value current column header is passed directly, instructing every cell of the constructed array to hold that same static column label regardless of its position. The third column is populated by extracting the data column that belongs to current column header. This is achieved through CHOOSECOLS function, where data variable is supplied as the array argument, referencing the interior values of RNG array derived earlier by dropping both the first row and the first column. The column number argument of CHOOSECOLS is set to column number, the variable established at the very beginning of the lambda function inside reduced loop through match function. This ensures that on every iteration, CHOOSECOLS extracts precisely the column from data that corresponds to the current column header value, aligning the extracted values correctly with the row labels and the repeated column label. The data is unpivoted. TRIMRANGE is wrapped around occurrence of RNG to automatically trim any accidental blank rows or columns from the user's selection, preventing the formula from crashing regardless of how loosely the source range is. Save the formula in Name Manager so it becomes callable on any cross-tabulated range anywhere, just like any native function. Subscribe the channel so every such time-saving Excel technique lands directly into your feed the moment it goes live. Thanks for watching.